Right. Good morning. So I will start the discussion. So here I will write down the discussion in this whiteboard, and I will show the questions using screen sharing. Otherwise, I send the paper to the WhatsApp group. So if you can open that PDF, right? Then you can refer the question. So here also I will show the question using screen share, right? Okay, so I will move the first question. So here there are 25 questions. In the exam, there are 15 questions, right? So here first I will discuss question number 1, right? So here you can see question number 1. What is question number 1? So in the exam also, usually first question, most of the time first question is given by scientists, right? So here what is the first question? Who are the scientists who discovered the electron, proton, neutron respectively, right? So electron was discovered by J.J. Thomson by using cathode ray experiment, right? Then electron was discovered by Ernst Rutherford by using anode ray experiment, otherwise canal ray experiment, right? Do you remember? By using perforated cathode, experiment was carried out. Then using that experiment, finally, Rutherford was discovered the occurrence of proton in element, right? Therefore, proton was discovered by Ernst Rutherford, and neutron was discovered by James Chadwick, right? So the experiment of discovering of neutron is not in the syllabus, right? So, but you have to remember the scientist is James Chadwick, right? Therefore, what is the answer? Answer is a second one, right? In the atomic structure lesson, there are a lot of scientists. You have to remember those scientists, right? So here only electron, proton, and neutron. Therefore, answer is second answer. Second question, first question, answer is second, right? Okay, then I will move the second question. Right, so this is a second question. Which of the following statement is false? Right, so you have to select the false statement. Right, what is the first one? By sharing two electrons between two atoms, covalent and dative covalent bond is produced. By sharing two electrons between two atoms, covalent and dative covalent bond is produced. Right, it is correct. Right, it is correct. So in both covalent and dative covalent bond, two electrons are shared between two atoms, right? So what is the difference between covalent and dative covalent bond? So I will write down the example. Second question, first answer. Now consider HCl, right? So here there is covalent bond, right? So here there are two electrons. This two electron is shared between both of these hydrogen and chlorine, right? And here I will draw the dative covalent bond like NH4 plus. So in NH4 plus, hydrogen, 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 hydrogen plus, right? So here also among these four covalent bond, one is dative covalent bond. Among these four bonds, one is dative covalent bond, others are covalent bond. What is the difference? In both cases, two electrons are shared between two atoms. So think this one is a dative covalent bond. So we can draw like this way: nitrogen, hydrogen, hydrogen, hydrogen. Here lone pair. This lone pair is donated to H plus, right? Therefore, this is a dative covalent bond. The difference is in covalent bond, one electron participate by one atom. This hydrogen atom participate one electron. This chlorine atom participate one electron. Given one electron, right? In dative covalent bond, both electrons are given by nitrogen, but in both bonds, two electrons are shared between two atoms, right? The difference is in covalent bond, one electron given by one atom. In dative covalent bond, both electrons are given by same atom. Here, that's the difference. This statement is correct, right? What is second statement? Melting point of magnesium is higher than sodium. Melting point of magnesium is higher than sodium. Right. So here both magnesium and sodium are metals. Both are metals, right? So melting point of metals depends on the strength of metallic bond, right? Melting point and boiling point both, right? Melting point I will write down as NP and VP. Melting point and boiling point of metals depends on the strength of metallic bond. Strength of metallic bond, right? With increasing the strength of metallic bond, what happens? Both melting point and boiling point increases, right? Then the strength of metallic bond depends on the radius of cation, radius of metal cation and charge of metal cation, right? With increasing the charge and with decreasing the radius, what happens? The strength of metallic bond increases. You understand? Melting point and boiling point of metals depends on the strength of metallic bond. It is increases, MP and BP increases with increasing the strength of metallic bond. The strength of metallic bond increases with increasing charge and with decreasing radius of metal cation. We have to consider the metal cation, right? So therefore, I will compare the cation of sodium is sodium plus and magnesium is magnesium plus 2. So therefore, you have to consider these two, right? When sodium plus and magnesium plus 2 are considered, charge of magnesium plus 2 is higher than sodium. Here plus 2, here plus 1, right? So therefore, magnesium has higher charge. Then you have to consider radius of these two. When we compare the sodium plus and magnesium plus 2, both are isoelectronic. Right? What is the meaning of isoelectronic? Both contain same number of electrons. Both sodium plus and magnesium plus 2 contain 10 electrons. Right? Therefore, isoelectronic. When isoelectronic species are considered, the species containing higher charge has lower radius. Right? Therefore, when we consider charge, what happens? Charge of magnesium plus 2 is higher. When we consider the radius of magnesium plus 2 is lower. Right? So magnesium plus 2 has higher charge and lower radius. Right? Therefore, the strength of metallic bond of magnesium is higher than sodium. Therefore, this should has higher melting point. Right? Therefore, we can write down like this way: melting point and boiling point. This side, melting point and boiling point increases. That means magnesium has higher melting point. So second statement is correct. Right? Okay. So in the as a second explanation, you can write down like this way, short way, right? So then you can understand easily. So write down this part. As a question number 2, second answer explanation. Right. So then I will move the next answer, third answer. What is third answer? Magnesium nitride is more ionic than sodium oxide. Magnesium nitride is more ionic than sodium oxide. Right. So here, the third answer, we have to compare the ionic nature of magnesium nitride and sodium oxide. Ionic nature, we have to decide which one is more ionic. Right. So here, what is the theory? In this case, to compare the ionic nature or covalent nature of these two compounds, you have to compare the polarization power of cation and polarizability of anion, right? Because both are ionic compound. To compare the ionic nature or covalent nature, to compare, right? You have to consider the polarization power of cation and polarizability of anion, right? So here I will write down like this way. Cation, when consider cation, charge and radius, and anion, charge and radius, right? So polarization power of cation depends on the charge and radius. Polarizability of cation depends on the charge and radius. So here cation polarization power. Polarization power. Anion polarizability. Polarizability. Right? So when consider cation with increasing charge and with decreasing radius. Then consider anion with increasing charge and with increasing radius. You understand? Polarizability of anion increases with increasing both charge and radius. Both should be increased, right? Polarization power of cation increases with increasing charge and with decreasing radius, right? So with increasing polarization power and polarizability, what happens? Covalent nature increases, right? With increasing polarization power and polarizability. Polarizability. What happens? Covalent nature increases. Covalent nature increases. With increasing covalent nature, what happens? Ionic nature decreases. Ionic nature decreases. Do you understand the relationship? With increasing these two, covalent nature increases. With increasing covalent nature, ionic nature decreases. Right? So these two factors depends on the this charge and radius. So you can remember only one should be decreased, but radius of cation should be decreased. All others should be increased. To increase the covalent nature. Do you understand? To increase the covalent nature, these three should be increased, only radius of cation should be decreased. Right? So therefore we have to compare these two compounds. Right? Therefore we have to compare the magnesium plus 2 and sodium plus. Magnesium plus 2 and sodium plus. Right? So when we compare the sodium plus and magnesium plus 2, we can understand charge of magnesium plus 2 is higher. Plus 2 plus 1. Right? Then we compare the radius. Previously, I told you radius of magnesium plus 2 is lower than sodium plus. Right? Therefore, charge is higher in magnesium plus 2. Radius is lower in magnesium plus 2. Therefore, when we consider these two, magnesium plus 2 has higher polarization power. Right? So this side polarization power increases. Right? Polarization power increases. Right? Then we have to compare anion. What is the anion? N minus 3, O minus 2. Right? When N minus 3 and O minus 2 is compared, this is the variation. N minus 3 has higher charge, minus 3, here minus 2. Therefore, this has higher charge. And when we compare the radius of N minus 3 is higher than O minus 2. Right? Because here also both are isoelectronic, same number of electrons are present. When isoelectronic anions are considered, anion containing higher charge has higher radius. Therefore, this one has higher radius and higher charge. Therefore, N minus 3 has a higher polarizability. Right? Therefore, we can write down polarizability variation. This polarizability. Right? So therefore, you can understand magnesium plus 2 has higher polarization power. N minus 3 has higher polarizability. Therefore, magnesium nitride is more covalent. Right? Magnesium nitride is more covalent. So here I will write down. When we compare the sodium oxide and magnesium nitride is more covalent. This side covalent. Covalent nature increases. Therefore, which one is more ionic? Sodium oxide is more ionic. Right? Sodium oxide is more ionic. what is the answer is given? What is the answer? Here, the statement is given as a magnesium nitride is more ionic than sodium oxide. Therefore, it is false, right? Which one is more ionic? Sodium oxide. Magnesium nitride is more covalent, right? Magnesium nitride is more covalent. Therefore, it is the answer. False statement is a third one, right? So you can write down as a short note this one, right? So this is a short note, right? By using short note, fourth statement, ionic bond is produced in between cation and anion. Ionic bond is produced in between cation and anion. Yes, it is correct. What is ionic bond? The electrostatic attraction between cation and anion. In ionic bond, there is electrostatic attraction between cation and anion. It is known as a ionic bond. Therefore, it is correct. It is very easy, right? Then fifth one. So you can write down as a fourth one. Fourth one, electrostatic attraction. Fourth answer, electrostatic attraction between cation and anion. Electrostatic attraction between cation and anion. Cation and anion is known as ionic bond. Is known as ionic bond. Electrostatic attraction between cation and anion is known as ionic bond. Is known as ionic bond. Right. So there is another bond. What is the metallic bond? Right. So in the metallic bond, right. So in the metallic bond also there is electrostatic attraction. What is the difference of metallic bond and ionic bond? In both metallic bond and ionic bond, there is an electrostatic attraction, right? What is the difference? In ionic bond, electrostatic attraction is present between cation and anion. As example, sodium chloride. Sodium chloride contain ionic bond, sodium plus Cl minus. There is electrostatic attraction between these two, right? So in the metallic bond, although there is electrostatic attraction between cation and electron, right? In the metallic bond, there is an electron cloud. Inside that electron cloud, cations are present. Then electrostatic attraction is present between cation and electron, right? In both cases, there is an electrostatic attraction here between cation and anion, here between cation and electron. That is the difference between ionic bond and metallic bond, right? So you have remember it. Then fifth statement. What is the fifth statement? Both molten and aqueous sodium chloride conduct electricity. Both molten and aqueous sodium chloride conduct electricity. What is a molten means? It is a liquid state known as a molten, right? That means a liquid and aqueous sodium chloride conduct electricity. Yes, it is correct, right? So you have remember to conduct electricity. To conduct electricity, what is the requirement? To conduct electricity, free electrons or free ions should be present, right? To conduct electricity, free electrons or free ions should be present, right? Free electrons or free ions should be present. So when we compare the metals like sodium, magnesium, copper, any metal, right? When we consider the metal contain free electron, therefore metal conduct electricity, right? Free ions are present between ionic compound in liquid, that is a molten state, and ionic compound in aqueous state, right? So in the molten state, sodium plus and chloride are separate to each other. Therefore, they are present as a free state. Therefore, when we apply potential, sodium plus cation move towards negative potential, negative electric field, and Cl minus cation anion move towards a positive electric field, right? It is known as a moving of current. And here also in sodium chloride aqueous state, sodium plus and Cl minus are separate to each other. Therefore, these two ions can be moved. Therefore, ionic compound in liquid and aqueous state conduct electricity, right? Ionic compound in solid state, sodium chloride solid, do not conduct electricity because in the solid state there are electrostatic attraction between cation and anion. It is known as ionic bond, right? Therefore, sodium plus and Cl minus are tightly bonded to each other by using ionic bond. Therefore, they cannot move, right? Therefore, remember, ionic compound in solid state do not conduct electricity, right? Therefore, generally these three are conduct electricity. Metals by using free electrons, and ionic compound in molten, otherwise liquid and aqueous state conduct electricity by using free ions. Ionic compound in solid state do not conduct electricity, right? Okay, write down fifth one. Metals conduct electricity by using free ions. Metals conduct electricity by using free electrons. By using free electrons. Metals conduct electricity by using free electrons. By using free electrons. By using free electrons. Metals conduct electricity by using free electrons. Then write down separately. Ionic compound in liquid and aqueous state. Ionic compound in liquid and aqueous state. Ionic compound in liquid and aqueous state. In liquid and aqueous state conduct electricity by using free ions. By using free ions. Ionic compound in liquid and aqueous state conduct electricity by using free ions. Then write down ionic compound in solid state. Ionic compound in solid state do not conduct electricity. Ionic compound in solid state do not conduct electricity. Ionic compound in solid state do not conduct electricity because sodium plus and Cl minus. Because sodium plus and Cl minus. Because sodium plus and Cl. Sorry. Because cation and anion. Sorry. Because cation and anion. Because cation and anion are tightly bonded by using ionic bond. Are tightly bonded by using ionic bond. Tightly bonded by using ionic bond. By using ionic bond. Right? So therefore you have remember metals and liquid and aqueous ionic compounds generally conduct electricity. Generally, right? In some special case like a graphite conduct electricity. Graphite is a non-metal, but graphite contains free electron. Therefore, graphite also conduct electricity. So, general example, the non-metal conduct electricity is a graphite, right? So, generally metals and liquid and aqueous ionic compounds conduct electricity, right? Therefore, second question answer is the third answer, right? Then I will move to the third question. What is the third question? In copper, how many electrons are present having L equals 0 and Ml equal plus 1 respectively? In copper, how many electrons are present having L equals 0 and Ml equal plus 1? Right. So, what is the meaning of L equals 0? L equals 0 means S subshell. Otherwise, S sub the energy level. L equal 1, T sub the energy level. L equal 2, D sub the energy level. Right? So L represent the sub the energy level. L equal 0 means S sub the energy level. Right? Then ML equal plus 1. So ML represent the ML known as a, so L known as a which quantum number? First quantum number, principal quantum number, then magnetic quantum number, then angular momentum quantum number, then this last one spin quantum number. Principal quantum number M, it represents the main energy level. Then magnetic quantum number, it represents the sub energy level. Angular momentum quantum number, it represents the orbital, and spin quantum number, it represents the spin, right? So L equal 0 is sub energy level, ML equal plus 1, it represents the some orbital, right? So when we consider the S sub energy level, it contains one orbital. What is the ML value? 0. When we consider the P sub energy level, there are 3 orbitals. What is the ML values? Minus 1, 0, plus 1. Therefore, P subshell contains plus 1 ML value. Then we consider the D sub energy level. There are 5 orbitals. What is the ML values? Minus 2, plus 1, sorry, minus 2, minus 1, 0, plus 1, plus 2. Therefore, D also contains ML equal plus 1. Then F sub energy level, how many orbitals? 7 orbitals. What are the ML values? Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 2. Right? Therefore, except S sub energy level, P, D, F are contained ML plus 1 orbital. Right? So that theory you have to remember. Right. Then we have to calculate the copper. L equals 0 electrons and ML equal plus 1 electrons. Right? Okay. So here I will write down the question. L equals 0. What is the 0? S subshell. Sub energy level. Sub energy level. Right? S sub energy level. Then ML equal plus 1 is present. It is present in P, D, and F. Right? Only S do not present. ML equal plus 1 orbital. Right. Then we have to consider the copper. What is the atomic number of copper? 29. Then I will write down the electronic configuration. 2p6, ps2, pp6, 4s1, 3d10. Right. So here there is a special thing. When we consider the copper, it presents as a 4s1, 3d10. Right. Generally, students are write like that. 4s2, 3d9. Right? It is false because electronic configuration of copper is rearranged like this way, because this configuration is more stable than this one. What is other example? There are mainly 2 examples in syllabus. Other one is a chromium. Chromium also generally when we electrons are added, we can write down like this way. Generally, we can write down right this way, but it is incorrect. Chromium also present like 4s1, 3d5 rearranged. Right? One electron of OS electron is moved to here. Right? Therefore, remember electronic configuration of copper like this way, last part, and chromium like this way. Right? Copper and chromium. Right? So this part is same. I will write on last part 24. Right? So this is electronic configuration of copper. Then we have to calculate number of electrons having L equals 0. That means we have to calculate the S electrons. Right? Then how many S electrons? L equals 0. 1s2, 2 electron, 2s2, 2 electron, 3s2, 2 electron, 4s1, 3s2, and 4s1, another 1 electron, altogether 7 electrons. Right? 6, 7. And ML equal plus 1. ML equal plus 1 is present in PDF. So So here no electron here. 2p6. Therefore, how many electrons? Having Ml equal plus 1, 2 electron. And here no electron. And 3p6, how many electron? 2 electron. And 3d10, how many electron? 2 electron. Right? Because orbital contain 2 electrons. Here also, all orbitals are completely filled. Therefore, 6 electrons. Therefore, what is the answer? 7 and 6. 7 and 6 answer is not present here. Right? 7 and 6 is the correct answer. I think as a printing mistake, 7 and 6 answer is not present here. Therefore, answer is all. This is the correct answer, right? This is the question number 4. Right. So here you have to select the two statement. Right. What is the first statement? Dipole moment of HCl is higher than HF. Dipole moment of HCl is higher than HF. Right. So when we consider the molecule having two atoms, right, we can say that dipole moment increases with increasing electronegativity difference. Only two atoms, right? You understand? Right. Therefore, the first one, we have to compare the dipole moment of HCl and HF. What is the electronegativity of hydrogen? 2.1. Fluorine 3. Hydrogen 2.1, fluorine 4. You have to remember the electronegativity values. Right? Remember, you have remember the electronegativity values in the interest. So these are the values. Right, then what is the electronegativity difference? We are write down delta En. Delta means difference, En means electronegativity. What is the difference? 0.9. Here what is the difference? 1.9. 3 minus 2.1, 4 minus 2.1, 1.9 is the difference, right? So therefore, HF has a higher electronegativity difference. Therefore, HF has a higher dipole moment than HCl. You understand, right? Okay, write down fourth one, write down like that way. Molecules having two atoms are considered. Molecules having two atoms are considered. Molecules having two atoms are considered. Dipole moment increases. Molecules having two atoms are considered. Dipole moment increases with increasing. Dipole moment increases with increasing electronegativity difference. 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 Right? Then write down this one. Therefore, among HCl and HF is more ionic. And remember, you have remember these electronegativity values because some students are thinking no need to remember the electronegativity values, but electronegativity values of group number 1, period number 1, 2, 3. At least 1, 2, 3 should be written. 1, 2, 3 is enough. 1, 2, 3 and bromine and iodine you have to remember. 1, 2, 3 and bromine and iodine. So here I will first write down this one. I will tell you there is a short method to remember the electronegativity values. Right, so electronegativity values of these elements you have remembered the A-level syllabus. So hydrogen remember 2.1, right? And remember lithium 1. You have remember lithium 1. Then by using this one, we can remember the electronegativity values of certain period 11, right? Lithium 1 and this side increases by 0.5. You understand? Lithium 1 increases by 0.5. Therefore, beryllium 1.5, 2, 2.5, 3, 3.5, 4.0. You understand? Lithium 1 then increases by 0.5. Right? Then we can remember the all other elements. Then here you have remember sodium 0.9 increases by 0.3. That means 1.2, 1.5, 1.8, 2.1. So here up to boron, so up to phosphorus increases by 0.3, then it is increases by 0.4. That means here 2.5 and here again increases by 0.5, that is 3. You understand? Sodium 0.9, it is increases by 0.3 up to phosphorus. Then here increases by 0.4, then increases by 0.5. Then boron 2.8, iodine 2.5. These things you have remembered, right? And here I will write down HP. So you can remember there is a computers, HP computers. So HP word you have remembered. Then cis. Cis word you have remembered. Cis. Right? In the organic chemistry, there is a word in isomerism part, cis and trans. Therefore, you have remembered cis. Right? And next one, NCl. Right? HP, cis, NCl. What is the HP? Hydrogen and phosphorus. What is the cis? Carbon, iodine, sulfur. What is the NCl? Nitrogen and chlorine. So electronegativity values of these are equal. Both hydrogen and phosphorus 2.1. Carbon, iodine, sulfur all are 2.5. Nitrogen and chlorine 3. Right? So electronegativity values of these elements are same. Therefore, you have remembered these words. You understand? So by using that way, you can remember the electronegativity values of these elements. These elements are enough. Right? Okay, write down this part, this additional part. Electronegativity values of some elements. Hydrogen 2.1, lithium 1 increases by 0.5 in second period. In third period, sodium 0.9, it is increases by 0.3 up to phosphorus, then increases by 0.5, 0.4, then increases by 0.5. Right. So then next statement, what is the next statement? Boiling point of H2S is higher than water. Boiling point of H2S is higher than water. Right. To compare the boiling point and melting point of molecules. So previously I told you to compare the boiling point of metals, we have to consider the strength of melting point. To compare the boiling point of molecules, we have to compare the strength of secondary interaction. Right. So as clearly here, for second, weakest interaction is LDF, London dispersive force. Then DP. What is the DP? Dipole interaction and hydrogen bonds. Right. So there are 6 types of secondary interaction: LDF, DP, hydrogen bonds, induced dipole, iron induced dipole, and iron dipole. Right. So generally, in the boiling point case, questions are given by using by using the molecules having this type of interaction. Therefore, I will consider only these 3. Right. So when consider H2S, it is a polar molecule. H2S is a polar molecule. How we decide the polar or non-polar? We have to consider the dipole moment. Right. It is a very big theory. I will not discuss here. So H2S is a polar molecule. Therefore, interaction is DP, and H bond, water plus and hydrogen bonds. Right. So it's a general theory, water plus and hydrogen bonds. What are the main example of molecule having hydrogen bonds? Water, NH3, and HF. Right. So here I will write down example: water, NH3, HF, H2O2, then N2H4. Right. There are a lot of examples. So generally, mainly these are the main examples having hydrogen bonds, molecules having hydrogen bonds. Right. So therefore, then we can understand boiling point of water is higher than H2S, right? So what is the statement? Boiling point of H2S is higher than water, therefore it is false, right? So the second one, write down this one. LDH, DPDAP, H4. So think in the question, there are two molecules having dipole-dipole interactions are given. Then what is the factor you have to consider? Molar mass, right? If interaction is equal, we have to consider the molar mass. With increasing molar mass, interaction, the strength of interaction increases, right? Okay, write down second one as a second statement. As explanation, you can write down this one. Third statement, when sodium chloride is dissolved in water, ion-induced dipole interaction is formed. Ion-induced dipole interaction is formed, right? It is false, right? When sodium chloride dissolved in water, in between sodium plus, right? What is the interaction here? What is the general theory? When ionic compound dissolved in water, what happened here? Sodium plus and Cl minus is present. Around this sodium plus, water molecules are present like that way. That means negatively charged oxygen is attracted to sodium plus and positively charged hydrogen is attracted to Cl minus like this way, right? Hydrogen attracted to Cl minus, oxygen attracted to sodium plus. Right? What is this interaction? Sodium plus is iron and water. What is a polar molecule? Right? If polar molecule is present, we use we use word dipole. Dipole word is used to indicate the polar molecule, right? And induced dipole word is used to indicate the non-polar, right? Induced dipole word is used to indicate the non-polar molecule. Dipole word is used to indicate the polar molecule, right? So therefore, remember in the second interaction theory, dipole word is used to indicate the polar. What is the polar molecule? Molecule having dipole mode, right? And induced dipole word is used to indicate the non-polar molecule, right? So here about the polar, it is iron, and iron word is used to indicate the iron. That means cation and anion, right? In the secondary interaction part, remember these three words. Dipole used to indicate polar molecule, induced dipole used to indicate the non-polar molecule, iron is used to indicate the cation and anion. So there is cation, therefore iron dipole. Iron dipole. Then what is the interaction? Iron dipole. In this statement is given iron induced dipole. Iron induced dipole means what should be the sign? Cation or anion and non-polar molecule. What is example? I3 minus. In I3 minus, in between I minus and I2. I2 is non-polar molecule. I minus is iron. Therefore, iron induced dipole. Right? So here what is interaction? What is this interaction? Iron induced dipole. You understand, right? So here iron dipole. Therefore, it is false. So in the second interaction part, you have remembered this one. Because secondary interaction, we can name the secondary interaction by using the two different species. Always interaction is present between two different species. As a two different species, polar molecule or non-polar molecule or cation or anion is present, right? Therefore, by using these two species, we can name the secondary interaction. You understand? That means the interaction present between polar molecule and non-polar molecule. What's the name? Dipole induced dipole. The interaction of between polar molecule and cation, ion dipole. Interaction between polar molecule and polar molecule, dipole dipole, right? Interaction between non-polar molecule and non-polar molecule, induced dipole, induced dipole. Two should be used. Do you understand? Right? So like that way, by considering the two species, that means that we have to consider what are the two species, the interaction is formed. Then by considering the two species, we can give the type of interaction, name of the interaction type, right? Okay, and the third statement, you can write down this one. So in this statement is given as sodium chloride is dissolved in water, ion induced type. It is false. It should be ion dipole. What is a polar molecule? Therefore, dipole word should be used, right? So generally remember, when ionic compound dissolved in water, ion dipole interaction is formed, right? So last part as a last write down generally, when ionic compound dissolved in water, ion dipole interaction is produced. Ion dipole interaction is produced. Ion dipole, right? Then fourth one, O2, SO3, CH4 are non-polar molecules. O2, SO3, CH4 are non-polar molecule, right? So we have to consider what is the meaning of non-polar molecule? Molecule having zero dipole, right? And polar molecule having some dipole moment. In the polar molecule, dipole moment is not zero. That is simple here, right? So here, how you decide the dipole moment in O2 molecule? First, we have to know the structure. Is O2 and SO3. This is a structure, and CH4. This is a structure, tetrahedral. Right? To decide the dipole moment, you have to draw the 3D structure. That means there's a trigonal plane, therefore as a trigonal plane you have to draw. So tetrahedral, therefore as a tetrahedral we have to draw, right? Then we know in the covalent bond, dipole moment is present towards the element having higher electronegativity, right? So here both are oxygen, therefore there is no dipole moment. It is a non-polar molecule, right? So generally we can remember molecule, think there are molecules having two atoms and both atoms are equal, then dipole moment is zero. If two atoms are different, it is a polar molecule. In some direction, dipole moment should be present, right? Like NO, when we consider NO, two atoms and both are different, therefore this is polar. Because this is the structure, electronegativity of oxygen is higher than nitrogen, therefore this direction, that is dipole moment. In here, electronegativity are equal, therefore this direction or this direction, there is no dipole moment, therefore this is a non-polar molecule, dipole moment is zero. We represent as a mu equals 0, right? And here, dipole moment present towards oxygen, right? Electronegativity of oxygen is higher than sulfur. And here, this direction, and here, this direction, right? So here, trigonal plane, geometry is a trigonal plane. Then what happens? All of these are cancelled, right? All of these are cancelled. Dipole moment is 0. Otherwise, using physics, you can think I think in the mechanics part there is a net force something, right? So think there is a some object is present here and equal forces are applied like this way, right? In three direction, equal forces are applied that way. Then what happens? Net force 0, like this way. When three dipole moments are present like this way in trigonal plane geometry, because angles are equal 120, 120, 120. Therefore, dipole moment is 0, right? We are known as these kind of molecules as a symmetric molecules, right? Trigonal plane geometry and all bonds should be equal. Then what happens? Net dipole moment is 0. So generally you can think like the net force When there are like this way, there are 3 poles, net force is 0, right? So then here tetrahedral, this one also symmetric. Dipole moment present here towards carbon, no electronic beam here and here, and all are cancels, right? All are cancels. Therefore, what happened? Net dipole moment is 0, right? So generally, net dipole moment of symmetric molecule, net dipole moment of symmetric molecules is 0. So this one also 0. Therefore, what happened? The all are non-polar molecule, right? Therefore, fourth statement is true. It is an answer, right? So here I will write down the what are the symmetric molecules, right? So generally you can remember like this way: linear, linear, like oxygen. Otherwise, I will write down carbon dioxide, right? Net dipole moment is 0, and trigonal planar, trigonal planar. So these are known as a symmetric molecules. Trigonal planar like SO3. So here carbon dioxide this way, SO3 like this way. Then third one, tetrahedral, tetrahedral, CH4. And there is no space, write down others. Okay, first write down as a fourth statement. Fourth statement, first write down this one. First write down this one. Fourth statement. This part, only this part, only this part, right? Right. So in the future, I will not do this kind of theory again, right? So one theory part, even the one paper, after that theory part, when same kind of question is given, I will not discuss in detail. I will just give you the answer, right? So here this is the first time, therefore, I will discuss the theory behind of this statement, not only the question, right? I will discuss the theory behind of that question. And these points you have to refer again and you have to memorize, right? At home you have to refer again and you have to memorize those theory, right? After this one, write down like this way: dipole moment of following shapes, dipole moment of following shapes, dipole moment of following shapes, dipole moment of following shapes is 0. Dipole moment of following shapes is 0. Dipole moment of following shapes is 0. They are known as dipole moment of following molecules is 0. They are known as symmetric molecules. 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 Okay, write down these three. Others I will write down here. You can write down with me. Write down these three. And 4 by 6 I will write down here. What is the difference between carbon dioxide and xenon F2? Here, carbon dioxide, electron pair geometry and shape both are linear. Here, electron pair geometry trigonal, bipyramidal, and shape is linear. Right? In this case also, fluorine towards fluorine, dipole moment is present towards fluorine. So this one both are cancels out. Both are equal. And these three lone pairs present in a trigonal plane, a symmetric trigonal plane, right? Therefore, all of these are cancels out, right? And there is another theory. Remember, always in lone pair, dipole moment is present outside the molecule, right? In lone pair, dipole moment is present outside the molecule. Therefore, here also it is a non-polar molecule. Dipole moment is 0. And here you have to remember these shapes. So now in this all of this example, all bonds are same, right? That is why dipole moment is 0. Think if one bond is different, then dipole moment is not same. Then that molecule become assignment, right? That may think like this here, CH4, like CH3Cl. Here there is a chlorine atom. Then what happens? This dipole moment is not equal to others. Then molecule become polar. Dipole moment is not zero, right? All the bonds should be equal and shape should be these values. This shape should be this one among one of the shape among these six, right? Therefore, remember linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral, square planar, geometry, dipole moment is zero. You can remember. Otherwise, by drawing the structure, simply you can understand, right? So here simply you can understand this one to this one cancel. Both are same opposite. Here both are same opposite. Both are same opposite. Then all are cancelled. Then net dipole moment 0. Here both are same opposite. Both are same opposite cancel. Same opposite cancel. Therefore net dipole moment 0. Right? And here what is the meaning of this one? This solid line indicate the bond present in front of the board, and this dash line represent the bond present inside the board, right? Right, then fourth statement, it is correct. O2, SO3, CH4 are non-polar molecules. Yes, yes, it is the answer. Right. Then fifth one, shape of ClF3 is a trigonal planar. Shape of ClF3 is trigonal planar. Right. So fifth one, ClF3. So central atom chlorine, lowest electronegative one. Always fluorine form how many bonds? Only one bond. One bond. Then chlorine contain how many electrons in the valence shell? 7 electrons. 1, 2, 3, 4, 5. 4, 5, 6 remaining electrons are present at the lone pairs. Right? Therefore, here there are 3 sigma bonds and 2 lone pairs. Then what is the shape? Shape is T shape. Electron pair geometry EPG. EPG. Electron pair geometry trigonal bipyramidal. Trigonal bipyramidal. And shape T shape. So here given as a shape of ClF3 trigonal planar, it is false. Shape is a T shape. And electron pair geometry trigonal bipyramidal. Okay, you can write down this one, fifth one, explanation fifth one. So here what is the answer? Fourth one is the answer. Question number 4, answer 4. Right, then question number 5, there is a calculation. What is the mass of oxygen present in 3.011 10 to the power 22 SO2 molecule? SO2 molecule. Right. So number of molecules are given. Therefore, first I will calculate the number of moles of SO2. What is the equation? Number of molecules should be divided by Avogadro constant. 3.011 10 to the power 22 divided by 6.022 10 to the power 23 per mole. So these constants are given in the paper, right? In the paper here initially the constants are given. Avogadro constant, universal gas constant, Planck constant, speed of light, right? Then what is the answer here? These two this cancels out. So 10 to the power 22, 10 to the power 23 means 10. 1 over 20. That means 0.05 moles. Number of moles of oxygen. Right? Then SO2 contains 1 sulfur and 2 oxygen. Therefore, stoichiometry 1 to 2. Right? So therefore, we can write down number of moles of oxygen divided by number of moles of SO2 equal 2 divided by 1. Molar ratio equal to stoichiometric ratio, right? So then number of moles of oxygen divided by 0.05 moles, 2 divided by 1. Then we can write down number of moles of oxygen equals 0.1. 0.05 multiplied by 2. Then we have to calculate the mass of oxygen mass equal number of moles multiplied by molar mass. This is the equation, right? So this 0 is the oxygen, mass of oxygen, right? So the number of moles 0.1. Molar mass of oxygen 60. Then what is the answer? 1.6 gram. 1.6 gram per ton. 1.6 gram per ton. Okay, write down this one. Question number 5. So here the increasing order of the electronegativity of nitrogen in NO2 minus, NO4 3 minus, NO plus, NO2 plus, NO3 minus. Right, increasing order of the electronegativity of nitrogen. Right, what is the theory here? Electronegativity of same element. Right? So electronegativity of same element depends on the 4 factors. What are the 4 factors? What is the main factor? First factor, hybridization. First we have to consider the hybridization, right? Then second factor, if hybridization is same, then what is the variation of hybridization? sp3 has a lowest electronegativity. That means the theory with increasing the S character, electronegativity increases. Right? Then you can remember sp3, sp2, sp is a variation. Right? sp3 has the lowest, sp has the highest. Right? First we have to consider the hybridization. If hybridization is same, then what's the next factor? You have to consider the charge. Right? You have to consider the charge. If both hybridization and charge are same, then what's the third factor? Oxidation state. You have to consider the oxidation state of nitrogen. Right? When we consider the charge, electronegativity increases with increasing positivity. Oxidation state also increases with increasing positivity. Right? Both charge and oxidation state, electronegativity increases with increasing positivity. We have to consider the positivity. Right? Then if all are same, then what is the last factor? Electronegativity of bonded atom. We have to consider the electronegativity of bonded atom. Right? With increasing the electronegativity of bonded atom, what happens? The electronegativity of central atom also increases. That is a theory, right? So you have to remember the 4 factors in order: hybridization, charge, oxidation state, electronegativity of bonded atom, right? So to get the answer, I think it is easy to tabularize. Uh, it is easy to use a table, right? So therefore here I will write down like this way. I will draw a table here, molecule, sometimes ions, molecule or ion, right? Then what is the first molecule? Here in the equation NO2 minus. So what is the structure? This one is a structure, right? So we have to consider only nitrogen. Therefore, I will indicate the only lone pair of nitrogen, right? Molecule of ion NO2 minus. The structure of NO2 minus is this one. So the structure of these kind of common molecules you have to remember, right? Then NO4 minus, NO4 3 minus. This is a structure, right? There is a theory to draw the structure, but the general molecules you have to remember, right? NO plus. This is a structure. Positive charge present in oxygen. And NO2 minus, NO2 plus, nitrogen, double bond oxygen, positive charge present in nitrogen. And NO3 minus, 1 double bond, minus, plus. Right? That is resisted. Like this way, you have to write down draw the structure of molecule of iron. In the exam, most of the time, this question is given by using common molecules, right? Most of the time, new molecules given. Most common molecule present in syllabus is given, right? Right. Then I will consider the first factor. What is the first factor? Hybridization. Hybridization. Right. What is the hybridization of nitrogen? 1, 2, 3. That means sp2. 1, 2, 3, 4. sp3. 1, 2. sp. 1, 2. sp. 1, 2, 3. sp3. sp2. We have found the number of sp pairs. That means sigma pairs and lone pairs. Right? Here 2 sigma pairs and 1 lone pair altogether 3. Therefore sp2. Right. So then we can understand, I told you, when consider the hybridization, it vary, electronegativity vary this way. sp3, sp2, sp to the variation, right? Then we can understand these two are sp, these two are sp2, and this one is sp3. Therefore, this one should have lowest electronegativity, right? Therefore, I will indicate as a 1. 1 means lowest one, right? Then these two should be 2 and 3. These two should be 2 and 3. These two should be 4 and 5, right? To indicate which one is 2, which one is 4, right? We have to consider next factor. If hybridization is equal, but the next factor, charge. You have to consider the charge with increasing the positive value, right? So now here no need to consider this one because this one is the lowest one. Therefore, no need to consider the charge. So here I will consider charge. What is the charge of nitrogen? 0. Charge of nitrogen plus 1. Right? Therefore, which one should be second? Which one should be second? This one should be second. That means the lower one. This one should be third. Right? So here I write down the increasing order of electronegativity. Therefore, this one is the 1 means lowest one. Among these two, this one is lower one. Therefore, it is 2 and this is 3. Right? Then to select the 4 and 5, I will consider these two charge. Charge of nitrogen in NO plus, what is the charge? 0. And remember, NO plus, but this positive charge is present in oxygen, right? Here we have to consider the electronegativity of nitrogen. Therefore, you have to consider the charge of nitrogen, right? Not oxygen, right? Therefore, charge of nitrogen is 0, and here charge of nitrogen is plus 1, right? Therefore, this one is highest one. Therefore, this is 4 and this is 5, right? If charge is same, here there is no same charge case here. If charge is same, then you have to consider the oxidation state similarly, right? If oxidation state is same, you have to consider the electronegativity of bonded atom. Then we can write down the answer. That is the answer. NO4 3 minus lowest one 1, NO2 minus 2, NO3 minus 3, NO plus 4, NO2 plus 5, right? Then what is the answer? NO2 minus NO4 minus 3, NO2 minus NO3 minus NO plus NO2 plus third answer. So this is the answer, third answer, right? Okay, write down. Third one is the answer, right? So remember, after this one, if charge is same, then you have to consider the what is the next factor? Oxidation state, right? So I will do the next question, then I will do the interval. Question number 7. Right. What is the question number 7? It is related to the atomic structure, unit number 1. Right. What is the question? Energy of second and third energy level of hydrogen atom is minus 228 kilojoules per mole, minus 146 kilojoules per mole respectively. What is the wavelength of red line of hydrogen spectrum? wavelength of red line of hydrogen spectrum. Right. So in the hydrogen spectrum, there are three series: Lyman series, Barman series, and Paschen series. Mainly three series. Altogether, there are five series. Mainly three series: Lyman, Barman, and Paschen. What is the Lyman series? Lyman series is created when electron is moved to the first energy level. When electron move from upper to first energy level, Lyman series and Barman series upper to second level, Paschen series upper to third level. Right. So here Lyman series we know it is present in UV region and Barmer series visible region and Paschen series IR region, right? So here energy level of second and third energy level is given. We have to calculate the energy of red line, right? Red line is created when electron is transferred from third to second, right? That is why energy of second and third level is given. And next one, 4 to second, 5 to second, and 6 to second. Red line is given when electron is transferred from second to third, right? So therefore, we can write down here like this is a second level, this is second level, and this is a third level. When electron is moved to the second to third to second, what happens? The energy of electron decreases. The decreasing amount of energy released as a radiation, right? Red color radiation, right? And here, why this red radiation is created? Because electron is transferred from third to second, right? Energy of third level is higher than second level, right? Therefore, when electron move from third to second, energy of electron decreases. That decreasing amount of energy released as a radiation. Do you understand? Right. So think this pen. When this pen is moved to here to Earth's surface, what happened? The potential energy of this pen decreases. That potential energy should be the decreasing amount of potential energy should be converted to something, right? Therefore, we can we can see there is a sound like a of sound, right? So like that way, when electron move from here to here, energy of electron decreases. The decreasing amount of something should be happen to that decreasing amount of energy. The decreasing amount of energy released as a radiation, right? Therefore, in here, this energy of energy of this red radiation should be equal to the energy difference between third to second. To understand, energy of this red radiation is equal to the energy difference between third to second. Therefore, we can write down the equation. Energy of red radiation is equal to the energy difference between third to second. Like always, energy of upper level is higher than lower level. Right. So, what is the energy of third level? Third level is given as a minus 146 minus 388 kilojoules per mole is a unit, right? Then what is the answer here? Minus 146 minus and minus plus 328, right? So 328 minus 146 means 8 minus 6 2, 12 minus 4 8, 2 minus 1, right? 182. Do you understand? Energy of radiation should be equal to the energy difference between 3 and 2. Right? Similarly, we can write down energy of next line, that is a 4 to second. Right? So energy of that color is equal to the energy difference between 4 to 2. Right? Okay. So now we calculate the energy of radiation. Then we have to calculate the what? Wavelength. Right? So what is the equation? Now here energy is given as kilojoules per mole. Right? That means the energy of 1 mole. So energy of 1 mole of radiation, we can write down E equal Hc over lambda multiplied by Na. Do you understand? Hc divided by lambda, this is given energy of 1 photon. Now here energy of 1 mole of photon is given, therefore you have to multiply it by Avogadro constant, right? Then what is the energy? 182, and here kilojoule is not the SI unit, therefore we have to convert to joule, therefore I will multiply it by 1000 joules per mole equal 6.646 10 to the power minus 34 joules second, right? Multiplied by C, 3 into 10 to the power 8 meter per second, and Avogadro constant 6.022 10 to the power 23 per mole, divided by lambda, right? Then we can cancel the unit, joules and joules cancel, per second and second cancel, right? And per mole cancel. Always, when you write down the equation, you have to indicate the units. Then you have to cancel the unit. You have to simplify the units, right? Because sometimes think student this is substituted kilojoule. Then we cannot cancel the kilojoule and joule. Then we can think there is something wrong. Do you understand, right? That is why always when you substitute values in equation, you have to indicate the unit. Then unit should be cancelled out. Now in this case, we can observe only meters is remaining in units. Other all units are cancelled. Therefore, lambda value, wavelength value, we can find out by using meters, right? Wavelength value we can find out by meters. So here what is the number? 6.626 and 3 and 6.022. These are the numbers present here. Lambda goes to here, right? 6.626, 3 and 6. Then 10 to the powers, here 34, here 8 and 23 means 31, right? 31 means minus 3. Minus 34 plus 31 means minus 3. Divide by 182 into 10 to the power 3. Right? This one you have to simplify. So remember in the MCQ, no need to simplify 100%. We can simplify roughly, right? You have to simplify roughly, then by considering the answer, we can select the correct one, right? So therefore, I will simplify roughly. So here that means I will here to here 60, not 60, 100%, not 60, roughly 60, right? Then 6.022, I will consider as a 6, right? Therefore, we can cancel 10, roughly 10. Right? Then here 6.626, then powers minus 3 here plus 3, that means minus 6 meter. This is a rough answer, not correct answer. 100% correct answer is the rough answer. And answer is given in nanometer. Therefore, to convert nanometer, I will multiply it by 10 to the power 9 nanometer. Then what is the answer here? These 3 cancels out and 10 to the power 3. That means minus 9. So here there is a 10, therefore 10 to the power 4. Therefore what happens here? Here 10 to the power 4, here 10 to the power minus 3, therefore this becomes minus 7, right? Minus 7. That means here 10 to the power 2. That means 622.6 nanometer. It's a rough answer, right? Rough answer. That means answer should be close to this one. Do you understand? Answer should be close to this one. Among these answers, what is the closest one? First one, 658. Therefore, correct answer 658 nanometers. Right? So therefore, there's another point. Remember, in the MCQ paper, this kind of simplification, no need to do 100% correctly. Simplify roughly, then get the rough answer. Then by considering this rough answer, we can select the correct answer, right? Okay, write down this one. Right, so now I will give you the interval. So now time is 10:37. Come back 10:55, right? 10:55. I will start the next session, right? Okay, come back 10:55.